Hey everyone, it's Mrs. Lawrence, and today I'm going to talk to you about adding polynomials. So, let's do this. So first, let's look at some vocabulary. So two terms that I want to talk about right now. Monomial is the first one, and this just means a single variable or a single number or a single term, if you will, of a letter and a number put together. So mono, that prefix means one. So all of these are examples of monomials. So 4x, 20x squared, y, w to the third power, they're all just a single term. They're either, like I said, a single number like -3, a single variable like a squared, or it's a combination of a number and variables. But we also have polynomials, and the prefix poly means many. So when we look at polynomials, it's just taking a bunch of monomials and bringing them together by adding or subtracting them. You'll know it's a polynomial because it will have an addition or a plus sign, an addition or subtraction sign within them, indicating that they're single monomials. So each one of these is a single term. So like 3a squared minus 5a plus 4. Each of these is a single monomial, but when we put the plus and minus sign in there, it makes it a polynomial. We're going to watch this quick video. I'm going to turn up my sound on my computer so you can hear it. It might be a little quiet, but we're not going to watch the whole thing. Just kind of refresh your memory a little bit from some stuff from middle school.
In algebra, we have lots of different names for different things. Expressions, equations, formulae, and identities are all slightly different versions of similar things. Then, within these, we have variables, constants, coefficients, and exponents to describe the different parts. We also need to know what the word polynomial means and the different types of polynomials. A polynomial can have constants, variables, and coefficients, and exponents that are 0 or higher. Polynomials can never be divided by a variable.
I'm not too concerned about you understanding this
This
part
last
right
one
now.
isn't a polynomial because the exponent is negative. Polynomials can only have positive exponents. So polynomials is a general name. We can divide this down into monomials, binomials, trinomials, and many others. Given that a monocycle has one wheel,
so mono is
a
one,
bicycle has 2 wheels, and a tricycle has 3 wheels, do you think you know the difference between a monomial, binomial, and...
So the difference being, so mono means it has one term, binomial would have 2 terms, and a trinomial would have 3 terms. Again, those plus or minus signs are separating each term. So when I look at this trinomial that's under the tricycle, I see 3 terms. I see 3a squared, I see 2b, and then I see 1. Those are all each individual terms. There's 3 of them within that polynomial, so it's classified as a trinomial.
A trinomial? I'm sure you guessed it. A monomial has 1 term, a binomial has 2 terms, and a trinomial has 3 terms. More than 3 terms we just call a polynomial. So which of these are mono, bi, or trinomials, or not polynomials at all?
So we're going to stop there because I don't want to spend too much time on that right now. But again, it's just important to know that a monomial has 1 term, binomial has 2 terms, and a trinomial has 3 terms. So we're going to keep moving forward here. So when we talk about adding polynomials, it's important that we know how to combine like terms. So being a former 7th grade teacher, I know that this is something that you probably covered in 7th grade and in 8th grade. So it might have been it's been a while, so let's quickly review it. So like terms refer to monomials that have the same variable but may have different coefficients. The variables in the terms must have the same power, meaning they have to have the same exponent. You can't have x and then x cubed. They're not the same. They have the same letter, but they're not to the same power. So looking at this example, which terms are like? So we have 3a squared b, 4ab squared, 3ab and negative 5ab squared. So think about it. Which ones of those would be alike? Again, same letters, same power. I hope you chose 4ab squared and negative 5ab squared, because again, they both have a, b, they both have a's, and they both have b to the second power. They have to be to the second power. So even though the others have the same variables, because there's, I see a and I see b here too, they're not to the same power. So like 3a squared b, that's like saying you have 2 a's and 1 b, which 4ab squared is saying I have 1 a and 2 b's. They're not exactly the same. They have to be copies of one another, okay? Can't be like, oh, well, they're close enough. It's got to be an exact copy of it. So constants are like terms. So sometimes students get confused with this, like 5 and 25. Those are both constants. They're just numbers. They're like terms. You could just add them together. Or 6 and 4. They're like terms because you can just add them together. So let's do some practice. Which terms are like? 2x, negative 3, 5b, or 0? Take a minute and think. Yes, it would be negative 3 and 0. They're the like terms. They're constants. 2x and 5b, that one has an x, one has a b. They're not the same. What about here? 3x, 2x squared, 4, and x. Right, 3x and x are like terms. Notice this does have an x, but 2x to the second power is not the same as just 3x. This has an exponent of an invisible 1. Over here, we have an exponent of 2. What about this one? Which terms are like here? 2wx, w, 3x, and 4xw. If you chose 2wx and 4xw, I have a mistake in there. There's an extra x. That x should not be there. I got a little carried away in my typing, but they are like terms. So this and this are the same. I tried to trick you by putting the w and x in different orders. They're both still there. Order does not matter. So when we talk about adding polynomials, if you can add numbers, you can add a polynomial. It is that simple. So when we add polynomials, we have to think back to combining like terms. And kind of when you were combining like terms in middle school, you were essentially adding polynomials. You just didn't really know it. So this first step is to underline the like terms. You need to identify which terms are like, because in order to add them, they have to be to the same variable to the same power. So I take this problem again, and I've underlined now the like terms. So I have x squared. So I'm going to look through the rest of the problem and see, is there any other x squared? There it is. I have another x squared. I have 1. Do I have any other constants? Yep, there it is, 5. 3x, he's a lone soldier, doesn't have any friends. He cannot be combined with anybody else. He's just going to be part of the answer, regardless of what the rest of it is. Like I just said, 3x does not have a like term. But then in step 2, we're going to add the coefficients of the like terms. Do not change the power of the variables. I've had students in the past that always want to try and change the powers of the variables. You cannot do it. Just leave them alone. You are just adding the coefficients. Remember, the coefficient is the number in front of the variable. That's what I'm saying. If you can add numbers, you can add polynomials. So what I've done here is I've grouped the ones I underlined in pink, x squared and 4x squared. I have 3x here. He did not have any partners. And then 1 and 5 I kind of grouped together. So again, x squared. So if I have x squared and then 4x squared, you have to remember that in front of every variable, there's a shy invisible 1. So it's really saying, what is 1 plus 4? It is 5. So we have 5x squared, then 3x, and then 1 plus 5 is 6. See, it's just adding numbers. So some people prefer to add polynomials by stacking them. If you choose to do this, you have to make sure you line up your like terms. I wasn't taught this way in school. There's nothing wrong with this way. I usually don't do it this way, but by all means you can if it makes sense to you. And a lot of people it does. So this is the same problem from the last slide. Notice how they're just stacked on top of each other. And x squared and 4x squared are on top of each other, and 1 and 5 are on top of each other. Because we want to group those like terms together. And then we can just add 1 plus 4 is 5, x squared, 3x just gets brought down. He doesn't have anyone to combine with, and then 1 and 5 get combined. And that's it. Don't try to make this smaller. Don't try and tell me this is like 14x squared. Don't take 5, 3, and 6 and now add them together. They cannot be combined. They are not like terms, right? They are not like terms. So go ahead, let's try stacking these polynomials. Again, making sure that we line up our like terms. So I have 2a squared and 7a squared, they're going to be stacked. 3ab and just ab, they're stacked. And then 4b squared minus 2b squared. I've now noticed, I'm looking at this, this is an error. All of this should be a minus sign here. This should be a minus sign here. I'm correct down here. I failed to change that, but that's okay. We're going to roll with it. So now if I combine these together, again, just add the coefficients. 2 and 7 is 9. 3 and 1 would be 4. And then 4 minus 2 would be 2. Okay? So go ahead and give yourself an opportunity to try these questions. Again, when you're solving them, you can stack them if you prefer to. Just make sure you line up those like terms. And that's it. And that's how it's done. Okay? So great job on getting through those adding polynomials. We're going to do some more practice with adding polynomials in our next building knowledge piece. Bye.